Hi, in the previous video, we got the state diagram as shown on the screen here. And what I want to do in this video is draw a state diagram. Okay, from the state table that we have on the screen, we want to draw a state diagram. Now, uh, our system is such that we can have four different states, right? You can have the state and we can call the first state, let's say it is 0 0. You can have another state here called 0 1. You can have another state called 1 0, and the last state is 1 1. Okay, and the idea of these states is basically that the first of these digits, right, the first of these digits represents x and the next digit represents y. So if you are on state 0 0, if you are on state 0 0, and you want to go into uh, uh, and you get an input of, let's say, a equal to 0. Okay, what happens then? You can see from the state table, right, that we move from 0 0 to 1 1, right? So you move from 0 0 to 1 1. So let me draw that here. When your a is equal to 0, what happens when a is equal to 1? You still move to state 1 1. What happens when you are in state 0 1? When you are in state 0 1, you go to 1 1 when you have a equal to 0. So from 0 1, you go to 1 1 when a equal to 0, and from 0 1 you remain in that same state if a equal to 1, right? So can you see how I am drawing the state transitions, how we move from one state into another state uh, as different inputs come in, and our system is in a different state. So if you are at 1 0 and you get a input of 0, so you remain in 1 0. So that's a equal to 0. And if you have got a equal to 1, you move up to 0 1. So that's a equal to 1. And lastly, from 1 1, you move to 1 0 if you have a equal to 0 as the input, and you move to 0 1 if you have a equal to 1 as the input. And lastly, what we want to do is, with each of these transitions, there is an output associated, right? So for example, if you are in 0 0 and you get an input of a equal to 0, what is the output? The output is b equal to 1, as you can see in the truth table. So you can write b equal to 1. And similarly, you can write b equal to 0 for this particular transition. And you can just fill it in for all the transitions, right? This is b equal to 0. This is b equal to 1. So let's take this for example. So when you are at 1 0 and you get an input of 0, you remain at the same state, but your output is b equal to 1. And similarly, you have b equal to 0 here, you have b equal to 0 here, and b equal to 1 here. So this state diagram kind of captures all the information that is there in this truth table, right? And what we will see in the next lecture is how we draw the state diagram first, go into the state table, from there we go into the truth table, and from there we get into the sequential circuits. And we'll see that there are some circuits that are so widely used, and how we can design those circuits.